In this video, I'll introduce the idea of an antiderivative. So at this point, you've gotten pretty good at calculating derivatives. If I give you a function, say something nice like a polynomial, so say it's like, I don't know, x cubed plus 4x squared plus 3x plus 5, whatever it is, some polynomial, then you can find the antiderivative in your sleep. You can find the derivative in your sleep. The derivative, d dx, so now we're going to find f prime of x, just comes out to be, well, you know the power rule, right? So the power rule tells us that if you have some x to the n, then when you take the derivative, the n comes out front, and it's x to the n minus 1. You know this. So this just comes out to be 3x squared plus 8x plus 3, right? The 2 comes down, so it becomes 4 times 2 is 8, and then now it's just x to the 1, so x, and then the 3x is just 3, because, well, you can think it's x to the 1 comes down, x to the 0 is just 1, or you can think you just keep the constant in front of x just goes to 1. Okay, so that's just using the power rule. What we want to do now is find the antiderivative, where the antiderivative is going the other way. I want to figure out what is the function, I'll call it big f of x, so that the derivative of that function is my original function. So instead of taking the derivative of this function, I'm going to ask, what function would I take the derivative of to get down to this function? And so here we have to be a little bit careful. The derivative of what would come down to give me, for example, x cubed. And you might be tempted to say, it's something like x to the 4th. Well, that's almost true, but what's the derivative of x to the 4th? A 4 would come down, it would be 4 times x cubed. But there's no 4 here, so I shouldn't have an x to the 4th, because then it's going to become too big. How do I get rid of the 4 being out front? You know, if I just had x to the 4th, and I take the derivative, I would have 4x cubed. But I don't want that 4 there, so how do I get rid of it? Well, I would have to get rid of it by dividing by 4. But I can only do that if I started off by having that 1 over 4. So if I start off by having this 1 over 4, then when the 4 comes down, it would cancel with that 1 over 4, leaving me with just x cubed. That is, if I want to get something that's x to the nth power, then what I need to start out with is 1 power bigger, x to the n plus 1, but since when I take my derivative, n plus 1 is going to come out front, and I don't want an n plus 1 in front, I need to then divide by n plus 1. So the antiderivative of x to the n is 1 over n plus 1, x to the n plus 1. It's like the opposite. Instead of having it come out front and go down by a power, you go up by a power and you divide by the thing that is going to come down. So for example, 4x squared, well, you can think it's going to go up by a power, so it's going to be x cubed. But now when I take the derivative, the 3 is going to come down, and so I need to divide by 3. I keep my 4 here, so I keep it as now 4/3. And now when I take the derivative, the 3 comes down, cancels with the divide by 3, leaves me with just the 4. Or in the case of 3x, which is 3x to the 1, that's going to go up to x squared. It's going up by 1, but then I need to divide by that. So I'm going to replace this 3 with 3 divided by 2, so that when the 2 comes down, I have 3 times x to the 1. And finally, the derivative of what gives you 5? Well, the derivative of 5x gives you 5. You could think it's this special rule, because if there's nothing here that's the same as x to the 0, that's just a 1. So that goes up to 1, and 5 divided by 1 is just 5. Okay, very good. So this is an antiderivative of this guy. In each case, I just increase the power by 1, and then I divide by that power, so that when I take the derivative, I get back to the original. I'm trying to play the game of derivative backwards. Now, There is one more thing you have to be careful with of antiderivatives, because while this has as its antiderivative this guy, if I added, say, a 2 at the end, it would still have the same derivative. Because the derivative of 2 would go 0 and that would go away. So you can think like no matter what number you put here, that's just going to lead to a plus 0 here. It's not going to make any difference. And so when I'm writing the antiderivative, you could put a plus 2. Or if you prefer, you can put a plus 21. You can put plus whatever you want at the end. And all of those will be antiderivatives of the original function. What I'm going to do, therefore, is instead of putting plus 2 or plus 21, is I'm going to just put plus c to denote some constant. You can always have whatever constant you want at the end, because when you take the derivative, I get back to the original function. Okay, that's how we play the game. Let's try one more example. Let's say I have a function like g of x that is the function, oh, I don't know, maybe something like x cubed plus 1 all over x. Okay, this is now a quotient. If we were finding the derivative, if we were coming down and trying to figure out the derivative, in order to figure that out, we would have to use quotient rule. And I'm not going to do it. It doesn't matter. I don't want to know what the derivative is. I want to instead answer this different question of what is the antiderivative. So I'm trying to solve what is the antiderivative. The derivative of what gives me this. But I'm just pointing out, if we're finding the derivative, we'd have to find the quotient rule. How do we do it backwards? Well, the quotient rule is not really something you can do backwards. You know, you might be tempted, well, maybe we can just find the antiderivative at the top. So this might be the temptation. You know, maybe you would say up top, maybe it's just going to be like this becomes x to the 4 1/4 using the rule, plus x all over 1/2 x squared. That might be a temptation here, but resist the temptation, because when I find the derivative of this guy, it won't give me this. Because just like when I find the derivative of him, I have to do quotient rule. When I find the derivative of this, I would have to use the quotient rule. And the quotient rule wouldn't give me this. It would be hold the bottom, drive the top, minus, you know, it'd be some mess. So this is not going to work. You can't just drive one piece and the other. Instead, to avoid all these issues with the quotient rule, we want to first change it so it no longer looks like a division problem. And so how can I change it? Well, I can just simply divide both pieces by x and make this x squared plus 1 over x, or x to the minus 1. Okay, so this is a more manageable problem now. If I have my g of x is x squared plus x to the minus 1, now I can come and try and figure out what is big G of x. For the x squared piece, this is the antiderivative. I'm trying to figure out what function has as its derivative this guy. For the x squared, I know it needs to be x cubed with a 1/3 out front, so when I take the derivative, when the 3 comes down, it'll cancel, leave me with just x squared. How about for the x to the minus 1 piece? You might be tempted again. Just following the rule, it would seem like you should increase it by 1, giving you 0, and then divide by the power. Oh no, this is no good. We don't want to divide by 0, right? Like if you try this game here, you're going to be dividing by 0. I don't want that. So this rule doesn't apply when the power is 0, because we'd break math. We'd be dividing by 0. So this is a special case. What is the antiderivative x to the minus 1? To figure that out, remember, x to the minus 1 is the same thing as just 1 over x. And now you just have to think back. What is 1 over x the derivative of? 1 over x, you recall, turned out to just be the derivative of the natural log of x. So if you think back, you have the natural log graph. It looks something kind of like this. Here's the natural log graph. I want to know what is the derivative? So this is, say, y equals the natural log of x. Then at this graph, at the point 1, the slope comes out to be 1. As you move along, like when you're here at, like, say, 10, the slope of this graph comes out to be 1 over 10. So it's a pretty incredible discovery we made before, that the slope of the natural log graph is 1 over x. So typically, when you're using polynomials, you just increase the power. But the one exception is if you begin with x to the negative 1, you can't go up to x to the 0 and then divide by 0. Don't want to divide by 0. Instead, think of it as 1 over x, and then that will have as its derivative, as its antiderivative, ln of x. This is the derivative of ln of x, therefore ln of x is the antiderivative of this. One more special note. ln of x is only defined for positive values. There's no negative values here for x in this ln of x graph. It's only defined when x is positive. And so if I have this function, 1 over x, I could put in positive or negative numbers. And so that gives me some problems here with ln of x, because if I plug in a negative number, it's not defined. And so you'll see me use the convention that when I find the antiderivative of 1 over x, I'll put in absolute value symbols. What those absolute value symbols are doing is they're insisting that they're turning whatever number inside is into a positive number. So I can still plug in negative 2, but then it becomes positive 2, and it works out. You can double check, find the derivative of this. It all works out the way you want it to. So this is an antiderivative of g of x. Big G of x, this is one of the antiderivatives of this guy. There are other antiderivatives. What are they? Well, I'll just change the constant. I could have at the end of this a plus 2. You'll still have this as its derivative. I could have a plus 3. So I'm just going to put a plus c for plus a constant. And so here is my antiderivative for my function g of x. Okay. Hopefully this video gave us a nice introduction to finding antiderivatives of polynomials. The way it works is you just increase the power, doing the power rule in reverse, with the one exception being if you have x to the negative 1, you have to remember its antiderivative is just ln of x, and we throw in those absolute value to avoid becoming undefined. ln is only defined for positive numbers, so putting an absolute value forces that to be positive. In the next videos, we'll be talking about how to find antiderivatives of other functions.